And we know what is the formula, C by mu1, V2 equal to C by mu2, V3 equal to C by mu3. If V2 less than mu1 means mu2 must be, let me put that one. So let me first condition, let me put it here. V2 less than V1. So what does it mean? If V2 less than,
incoming call from Ecart Logistics.
okay, let's assume that three different mediums. So what I have displayed here, then mu1, mu2, mu3. There are three mediums, are the medium 1, medium 2, medium 3. So let me indicate here. There's a medium 1, medium 2, medium 3. Speed of V2 let be greater than V1. So with V2 less than V1, so mu2 greater than mu1. So where the speed of light, here the condition is a mu2 greater than mu1. So speed of light here, mu2 greater than mu1. So speed of light in the second medium will be less compared to medium 1. So then I can put a condition that based on this, medium 2 is denser than the medium 1. I'll put further a condition, let V3 less than V2. In that case, mu3 will be greater than mu2. Medium 2 is denser than medium 1, and we can conclude that here medium 2 is denser and medium 1 is rarer. Here if I further put a condition that V3 less than V2, if V3 less than V2, then mu3 greater than mu1, then speed of light in the medium 3 is less compared to medium 2. Then what is the conclusion we can make? It is like a medium 3 is denser than I'll write with respect to medium 1. Here is denser with respect to medium 2. What is the conclusion we can make it now? Medium 3 is denser, medium 2 is rarer. So is this denser, rarer? Are they absolute? No. Compared to medium 1, the medium 2 is denser. Compared to medium 3, the medium 2 will become rarer. So the medium 2, if I compare with medium 1, will become denser. If I compare with medium 3, it will become rarer. So like this, a given medium, we can say denser, rarer with respect to some other medium. This medium 2, what is it? Is it denser or rarer? No, I can't say. It's not absolute. Denser, rarer is not absolute. It's a relative one. We can compare whether a given medium denser or a rarer relative to some other medium. So therefore we use word like a with respect to. I think this is with respect to or relative to, either of one, with respect to or relative to. So like this now we can study the propagation of light in various mediums. There's one basic difference what we can make it here. Now, what will happen to the other parameters of the light as the light propagates through a medium? What will be the other parameters? What do you mean by other parameters? Means like the frequency, the wavelength, because the speed of light will change as it propagates from one medium to other medium. Anything will happen to its frequency and wavelength? No, the frequency of light depends only on the source. As the speed of light changes, definitely the wavelength of light has to change. So here only we can write it here now. Suppose F equal to V by lambda. V further we can write it as C by mu. Then F equal to C by lambda naught. Okay, I'll do one thing. Let me put it here. It will be much convenient for you. No, this is thing. So F by C equating these two. So F equal to, I'll substitute this here. So C by lambda naught equal to C by mu lambda. Lambda equal to now lambda naught by mu. What is lambda naught? Wavelength of light in vacuum. What is lambda? Wavelength of light in medium. So in different medium, the speed of light will be different, the wavelength will be different, the frequency is going to be same. So this is for in vacuum it is. In any medium, there's a formula. Okay, speed of light, like how the frequency and the speed and the wavelength of light is in any medium is given by F equal to V by lambda. In vacuum, F equal to C by lambda naught. Then how that wavelength of light in different mediums are related in terms of refractive index, we'll make it a generalized formula like this here. Can we say anything about the wavelength of light here? Because the frequency is going to remain same. If speed of light increases, then the wavelength has to increase. If speed of light decreases in medium, the wavelength has to decrease. So what we can write here? Lambda 2 less than lambda 1. Or here only I'll write it. Lambda 2 less than 1, lambda 1. Now what about here comparison? V2. So here lambda 3 less than lambda 2. The next question comes like speed of light changes as it propagates, as it moves from one medium to another medium. Wavelength of light is also going to change as it propagates from one medium to another medium. What will be the frequency? Frequency is going to remain same. It depends only on the source. Okay, one more parameter called like a visible light. If you take it, something the color so is what very essential one. When you take the visible light, Vibgyor, we can take example of the visible light Vibgyor. So the violet color ray of light as it propagates from one medium to another medium, anything will happen to that color. Yes, the color is a parameter of frequency. So definitely the violet color propagates from one medium to another medium. Yes, it is going to remain as violet only. Okay, this one. So this is about the basic idea of the when a ray of light propagates from one medium to another medium. Okay, let's go for the some small basic idea based on these things. Some small related numericals we'll discuss. Then I'll start the Snell's law, which is very much required for us.